Hello, this is lesson 10, part 2. This is a covariance example. In this example, we're looking at the experiment of rolling a pair of dice. Now, the x and y variables are defined as follows. X is the value of the first roll, and y is the sum of the values. And we're going to look at the relationship between those two variables. Roll 1, x, and y is the sum. So what we have here is a chart of all 36 possible outcomes when you roll a die twice. And the probability of any one of those outcomes is just 1 out of 36. So the P of xy is 1 out of 36, which in rounded form is about 0.03. And so each row here consists of the two values on each die, their sum, and then we're going to calculate the expected value of xy. So we need to calculate x times y. We need to calculate the probability of that expression and then multiply them together and take the sum. So if x and y are both 1, the sum is 2. The product of x and y, to be careful here, we're multiplying x with the sum. 1 times 2 is 2. The probability of that happening is 1 out of 36. And then we multiply xy times p of xy to get ready for the expected value. And so we repeat that process for all 36 possibilities here. And so the sum of this last column there is the expected value of xy. Expected value of xy is the summation of xy times p of xy. So now we're going to calculate the covariance. So the covariance formula is expected value of xy minus e of x times e of y. Now we just calculated the expected value of xy. It's 27.42. The expected value of x, it's a single die. Roll 1 is a single die. We did that already, and that is 3.5. Now, y is the sum of the values. What's the expected value of the sum? So it is the sum of the expected values. So it's 3.5 plus 3.5, roll 1 and roll 2. So the expected value of the sum is 7. Now you can do that the long way there with listing all the different possible sums there and doing out the definition, but we can use the property there of expected value of a sum to just do the expressions one at a time. And so we just do 3.5 for the first roll plus 3.5 for the second roll, which is 7. And so that's where the 7 comes from. So the covariance, expected value of xy minus e of x times e of y, 27.42 minus 3.5 times 7. 27.42 minus 24.5 is 2.92. So it's 2.92. So what that's saying is that there is a positive, somewhat positive relationship here, small positive relationship between x and y. So the largest possible values of y will correspond to bigger values of x, but there is some variation here. X is 1, but y could range all the way from 2 through 7 because the second roll is playing a part here. But overall, the general trend is upward. As x gets bigger, the sums do also get bigger, and so we do have a positive covariance here between the between roll 1 and the sum. Now, later on in the course, we will look at situations where we have, more than one variable, and we may revisit some of this stuff. All right, as always, please don't hesitate to email if you have any questions.